So good morning, good afternoon, or good evening, depending of your time zone. Thank you very much for joining the Analytic Tableau user group today. Today it's very early for me because we decided to do like an APAC series for this time. So let's go through what is the Analytic TUG very quickly. The Analytic TUG is around Tableau and Analytic, as his name stands for. We have like a virtual event almost every month, and it's around Analytic all the time. So if you haven't registered, subscribed yet to the BV page, please do so to be informed of our next event and when the recording hits YouTube. All our recording are in YouTube, and we have the proud leader of the Analytic TUG. So we have Shimdi, who is currently sleeping because he's in the US. He's a database designer and developer at Peace Sites Analytic. I have the pleasure to be joined today by Prasam, who is fully awake like me. He's a senior BI engineer at Emirate NBD. And myself, we haven't found a job, so I'm still enjoying life, guys. And voila. So yes, a little more detail about us. So myself, I have worked as a Tableau enablement and analytic lead. I discovered Tableau 10 years ago, and I fell in love immediately. I have to put how many V's of the day I have, even if I sound ridiculous in comparison of Prasam and Shimdi, but because we have put it, let's put the data. And I am co-leading the enablement and Data Plus Women webinar series plus from this Analytic TUG. And I love baking for other people French pastry. Here it's my YouTube channel that you can check. Then we have Prasam, who is a visionary and an ambassador. He fell in love also with Tableau, and he started like giving back to the communities. That's why he found like Tableau Buddy and this dinner. He has 4 V's of the day, and he has a very big, strong sense of community building and mentoring. So I recommend you to follow him if you haven't done that yet. And yes, he loves food and anime like me, but that's that's a good thing. And then we have Chimdi, the freelance and contract data visualization for clients in retail, media, education. He has 14 V's of the day. The guy is like amazing what he does in Tableau Public. You should check it out. He also co-lead Makeover Monday, and he participated on the challenge. He said about himself that he's a Viz junkie and he enjoyed documentary. So let's start up about our program, but before some ground rules. The only rule here is to enjoy. The session is being recording, and if you want to chat, please use the chat box. But if you have a question, please use the Q&A because it will be easier for us to monitor. So thank you very much. And now I will let Prasam introduce our speaker, starting with Alex, who has to start first.
Great. Okay, so hi everyone, and thank you so much, Annabelle, for giving us that great introduction. And we have already been done with the introduction. Now, I think here a bit of change. So Alex will be going first. He's going to speak about Think Like a Hacker, how to develop more maintainable dashboards, followed by Joon, who is going to talk about how to drive Tableau dashboards with the user input. And then we have Chris, who is going to talk about leveraging Snowflake, DBT, and Tableau altogether. So right away, I'll go to our amazing speakers. So first we have Alex. You can follow him on Twitter. If you haven't, you can just search this keyword GN Genetis or GNETIS, however you would like to spell it. And he's a seasoned data and analytics professional based in Auckland. He's originally from Germany and he moved to New Zealand in 2015 and quickly adopted Tableau. Currently, he's an analytics founder and director at VisQ, and he's helping businesses to unlock deeper insights and he has been an active member of the Tableau community and has been hosting Auckland Tableau user group for 8 years. That's huge. And apart from that, he is also one of the core members of Visit Sydney. If you don't know about it, if you are in the Asian part of the world or towards Australia, I think you must check out his content as well as the Visit Sydney that is going to happen, I think, just in a week. So over to you, Alex.
Sweet, thank you. Yeah, if you haven't heard about Visit yet, it's too late. We are all booked out. There's only a wait list up. So I'm sorry for that.
You can pass on my ticket to someone, Alex.
I didn't see you didn't register, Prasam. I'm pretty sure I looked at that and I didn't see you.
I thought I was in your favorites.
Shame on you. Shame on you. Sweet. Thanks for that. So I want to talk to you about how you can save days of your time doing things slightly different. In fact, I talked to somebody about a year ago who was able to save up to 5 days each month by thinking like a hacker and applying the kind of techniques that I want to show you today. Now, as a child, I always thought being a hacker is pretty cool. You stare at black screens, you let machines do the work, and you get lots of things free. Now, if you recognize the last screen or if you laughed about it, the recording of this, as well as the attendee list, will be passed on to the authorities for you to get in touch with you. These days, my apps have a dark mode. I do let the workflow tools do the work, and I get free time from that. So really, I think I made it, and I'm a hacker. So what I want to show you today is what I've learned over the years, what makes my life easier and sort of makes my work a little bit easier, and how you can do the same. And that is through using basic development techniques to save you and your colleagues a lot of time. Now, all of these techniques are very generic. The examples are obviously Tableau based. But if you understand the concepts, you can apply them in Excel, in SQL, in your databases, if you develop in Salesforce, or use any other programming or developing language or platform for that matter. Do we have the raising hands thingy here? No, we don't. Oh, yeah, too bad. Okay, so we'll skip over that, and I'll just ask you to sort of think about it yourself. And sort of answer the next 3 questions for yourself to see if you fit in that category. When I do it in person or on Zoom or so, I'll let people either sit down or raise their hand. So in this case, if you have duplicated production workbooks, that'd be a problem. So duplicated production workbooks, think about things like having a sales workbook for the Western and the Eastern region, or having the same workbook for different clients to see the same data, or these kind of things. You repeat the exact same workbook, you just filter it down to different things. The second aspect is if you do the same task over and over again. So that might be every month you open a workbook and change a filter or refresh the data because something in the data changed. Or one of your workbooks on a regular basis breaks with the same problem. And the one thing you need to do is, I don't know, add a new line into a case statement or these kind of things. And the last one is if you get requests from your users when they complain that they break your dashboard, and break is in quotation marks here because it's usually something where you look at that and you're like, no, it's not broken. You just did the wrong thing. Like, I didn't expect you to do that, but you did it anyway. So now you end up with a weird visual. So if you just reset the vis, it'll all be fine again. So if any of these things apply to you, rest assured, you are not a bad developer. That's the good news. The bad news is that after this presentation, it will be your fault because you know how to avoid them and how to work around these things that they don't happen. If you are in any of these situations, there's a few reasons why that might be the case. You might be unexperienced with what you're doing, and that might either be because you don't know, you maybe have a business background and you don't really know about development techniques and certain concepts that apply. You might be a seasoned developer, but only in SQL or other programming languages. So Tableau has a few concepts and ideas that don't really have an equivalent in SQL, for example. So you need to think differently about that. And if you don't know that Tableau does that, you might not know how to solve a problem like that. We have business timelines and requirements. I think we all have been in a situation where a high up comes to us and tells us that something needs to be there by tomorrow morning. And the only thing we can do is pull an all-nighter and try to make something work. And it might be a lack of self-confidence. You might be new in your role, you might be early in your career, and maybe you just don't feel that, or you know that something is wrong, but you don't really feel like it's your position to speak up and ask for something to be done differently. Maybe the project is already underway and actually changing something seems to be too late in the project, these kind of things. So that's the kind of things that I wanted to talk about to you. Before we do that, a little bit about who I am and why you should even listen to me. My name is Alex. Prasan already mentioned it. I was born in Germany. I moved to New Zealand about 11 years ago. For 10 years, I work with Tableau now. For about 17, 18 years, I work with data. And for about 20 years, a little bit longer, I work with development and coding in one way or the other, which seems like an insanely long time, to be honest. And about 1.5 years ago, I was made redundant, so I started my own little thing called Visku, and I help small and medium-sized businesses to make the most out of their data and sort of get insights that they might not have received otherwise. What I'm going to talk about today is partly personal preference. I hate doing things repeatedly, and I can't stand doing something that I know will cause issues down the track. And part of it is professional experience. I worked for about 10 years in consultancy. I worked on a few well-designed systems, but I also worked on a lot of really badly designed systems, and I had to fix a lot of mistakes, often that others made, mistakes that I made, because at the time I didn't know it better. And 6 months, 12 months down the track, I realized that something could have been done better, and I had a ton of work to actually fix the problem that I introduced. And the reason that I actually did this talk is because I learned development a few times in my career, but it always focuses on the technicalities. How do you do a case statement? What is a for loop? What is a data structure? These kind of things. But it very rarely focused on the kind of efficiencies and best practice that you could and should apply to make your and other people's lives easier. So that's sort of a summary of the best practices that I would consider worth looking into. And they're all guidelines. It's all best practice. It's nothing is the law. You decide in each situation if you actually can apply it, if you should apply it. And if you decide against it, it's fine, as long as you do it in a considered way and you know why you do it. We'll talk about 3 different things, something that I call the 1, 2, 3 rule. We will try to look into the future. And then at the end, we do what every good hacker does. We try to break things. You are welcome to ask questions in the Q&A. At the end, you'll get a link to 3 blog posts that summarize all of these things and give additional examples. And if we have time, then I'll try to answer them. Otherwise, get in touch with me via LinkedIn. And I'm happy to answer any questions there. So we start with the 1, 2, 3 rule, which is sort of the version of an English saying. I forget the accurate saying, but a famous American paraphrased it something like this. Now, a little bit more articulated than that. What that means is if you need to do something one time, you just do it. You don't really need to think about the long-term implications of that. You just go ahead and solve your problem. If you do it a second time, usually the easiest way is to just copy what you did the first time, slightly adjust it, and then go with it. You might change things around already, but that's usually an additional amount of work that you might not really want to do. If you need to do something the third time, however, you should really consider changing things. Because if you do things 3 times, chances are you do it a 4th, a 5th, a 6th time, a 10th time, a 20th time. And at that point, if something needs to change afterwards, if you have a bug somewhere, the amount of time that you spend fixing it and trying to adjust for it becomes really, really high, and you might block yourself down with trying to fix these things when you could make your life and other people's life a lot easier. So a real life example of that is that one person I talked to about a year ago had a workflow There was something like that. They got data from an API, put it in a database, then they ran a prep flow to manipulate the data, wrote it back to Tableau in this case, and then created a dashboard to provide it back to the client. That was great. And then they got a second client. So the easiest thing to do was copy the whole thing, change a few things around, and create 2 workbooks in the end on Tableau and provide those to the client as screenshots in this case. Now, business went really well, and they ended up with about 100 clients. So that meant 100 workflows, 100 prep flows to run, 100 workbooks to refresh, 100 screenshots to take, and 100 emails to send to clients. That took up to 5 days each month, and the ambition was to go up to 200 customers. So you can clearly see that that doesn't scale, and things should be done differently, because otherwise you just spend half of the month just refreshing the data, which is obviously not what you want to be doing. This is definitely the most extreme example I came across, but there are other clients I work with that have close to 10 iterations of sort of a similar kind of workflow, or 10 different views for different clients or regions or whatever it might be. So if you take anything away from my call today, or from my presentation today, please don't do that. If you do things that often, something is wrong and you need to do it differently, the sooner the better, because otherwise it'll come back and bite you. A few other examples there, as we already mentioned, the workbooks that are copied for different business units, for different regions, for different clients, whatever it might be. You might use the same filter every time you create a new workbook. You might have a source that you connect to, and you always filter out deleted records or test records, or you might always filter out the orders that were returned, these kind of things. You might know that, but if somebody else works with the data that isn't you, somebody outside of your team, or you get somebody new in your team, they might not know that, and it's really easy for them to just ignore that, build a visualization, a dashboard, put it in the next board report, and before you know, the whole company runs on the wrong numbers because they forgot to set that 1 or 2 different filters. And you might have the same calculations in every workbook. If you have something like a profit ratio, that's really easy to calculate. But I've seen complex 200-line case statements to look at certain values, replace them by others, or create, based on complete logic, a certain hierarchy or categorization. There's usually a better way to do that. And if you actually do that and copy it over and over again, at some point you will find a bug, and then you need to fix it, and you need to fix it 5, 10 different times. And I can guarantee you will not do it consistently, and you will run into problems there. A little bit more generically, it typically looks like that. You get an input, you want to transform it somehow to calculate something different and have an output. That could be something very little, like a different flow, like I showed with my client. But it could also be something very small. For example, you have revenue figures in your workbook and you want to calculate year-on-year growth. The input is the revenue, you calculate something, that's the transformation, and the output is the year-on-year growth. You do it once, great, easy. And then you might get a use case, and you might want to have the year-on-year growth not only for revenue, also for items sold, for example. The easiest thing there to do, if you use Tableau a lot, is probably just copy the calculation, replace a few values, and then off you go. And that is usually the easiest thing. And then it goes on. You need to calculate the year-on-year for profit as well, the number of orders, maybe a few other metrics. You also want to compare all of them against the previous months and against the month last year, forecast, budget, projection, you name it. And before you know, you end up with 20, 25, 30 different calculations, where you probably could have gotten away around 5 or so. And typically, all of these steps are identical for each version. You just slightly adjust the measure or dimension or these kind of things. And once it grows, the problems come up. Imagine the year-on-year growth should have 1 decimal instead of 2. Or you don't want the percent difference, but the percent to the previous year, for example. And before you know, you need to change it 4, 5, 6, 7 different times and make sure that it's all consistent. So what do we want to do instead? What we want to do instead is to bring all the inputs together as early as possible, do the transformation once, and then get 1 or multiple outputs if necessary. So typically how you would do it in Tableau is you might union different data sources or different data sets to make sure that you don't need to run it on different tables. You might want to pivot your measures. So if you imagine the example before, you have profit, revenue, number of orders. If you don't have it in different columns, just in one column in different rows, you create all of these calculations just once, and switching from one metric to the other is as easy as changing a filter. If you get a new metric in your data set, you don't need to do anything. It just appears in the filter, and the user will be able to select that. A few other options to consider there is you can think outside the box. What I usually do is ask a client if their requirement is even valid. So if you think about your different dashboards for different regions of sales, for example, is your data really so secret that it needs to be in different dashboards and people can't see each other's data? For external clients, that might be an easy answer and say, yes, it is necessary. But for internal data, in most cases, it's not. It's not that confident that it needs to be that much separated. So you could just all bring it together. If you do have the requirement, you can use row-level security. You can do it in virtual connections in Tableau quite easily. And that is really secure. And whenever somebody accesses the data, they can only see what's meant for them. The other thing that people who work at Tableau usually don't really like to hear is that Tableau is not always the answer. Tableau is a great reporting and visualization tool. It's not an integration tool. It's not a database. So you shouldn't really try to use it as one. You can use row-level security in a database, which is usually more maintainable and a little bit better to handle. You can use something like Tableau Prep to move and manipulate the data, or you can use tools like MuleSoft, Alteryx, Fivetran, or anything else to integrate the data and let them do what they do best, and then use Tableau for the visualization. And then lastly, you can create templated solution. So that's sort of what I talked about before. One workflow that to transform everything, and the only thing you need to do is reuse that one workflow, dump something in there, and then take the output of that. So really what I want you to do is to be lazy. So if something seems very cumbersome, and chances are that there's an easier way, so do some research, ask somebody who's more experienced to see if they can come up with a way that is easier. Now we try to look into the future. We will not need a crystal ball, and it will not help you to win the lotto. But there's a few predictions that we can make about our data. The first thing, something certain, months and years will change. It's 2025 right now. It will be 2026. If you set a filter to only include 2025, the dashboard will be empty in January next year. Some things are a little bit less certain. Names of companies, people, products change. Facebook famously rebranded to Meta. So you shouldn't really use these things in your logic. And if you do, you should consider what happens if they change. And then very uncertain things. A previous boss of mine always talked about the big red bus test. Will something still work if I'm hit by a big red bus on my way to work? That's quite extreme, but you can clearly see how you might be sick for a few weeks, or you might leave your job. You might work in a different team in the same company, and all of a sudden you are not there to solve these problems anymore. So that's things you should consider. And to think about how you can approach that is, the first thing is to make it dynamic. I already talked about the years, for example. They will change. I basically never use an absolute date filter in a dashboard because the data will change and it will break at some point. So there's the relative dates. You can use today to anchor to today. You can use minimum or maximum to find sort of dynamic anchors in your data that you want to use You can use relative date filters to use the last 3 months, the next 12 months, last quarter, whatever it might be. Another common thing is to fix the axis. Usually you do it for layout purposes because you want some more white space for annotations or something. That is great until you fix the axis to, say, $10,000, and suddenly you have a banger of a month and you sell $15,000 of goods, and your values are literally off the charts and you can't see them anymore. So try to not fix these things, and find other ways, work with reference lines or something to push things out dynamically to have the space that you need to work with. You can make it more generic. Something I sometimes see is, especially in SQL queries, take everything except where the ID is 1001. That was great at the time. It probably worked. But whenever I asked why that was there, nobody knew it anymore because the person who initially wrote it wasn't in the company anymore, and nobody knew what that ID meant or why it was taken out. So there's better ways to do it. Filtering on an ID in itself is better than filtering on a name, because as we established, names can change. But IDs don't really tell you anything, and you don't really know why you filter something at all. So the way to solve that is to step back a little bit and see, okay, what other attributes are there that we could filter? And say in this example, we want to filter out Alice and Carl. We can look at which offices they work in. That's Auckland, Wellington. That's already something that I can implement. And it makes it a lot easier. It's basically self-documenting. I can see, okay, I want to exclude those offices. I don't really know why yet, but it's a little bit better. But then what happens if we hire Felix here in Christchurch? So should we include him? Should we exclude him? We don't really know about that. So we can step back a little bit more. We have an APAC audience, so I expect all of you to know which countries are those cities in. And if you look at that, it's very clear that, okay, we want to exclude Alice and Carl. That's New Zealand employees. So Felix in Christchurch, we probably want to exclude as well, because he would also be in New Zealand. And at that point, I would consider that basically self-documenting, because we see, okay, we probably just want an Australia focused data set. It's a report for Australia. There's not really a lot more that needs to be said to that. But there's one more thing that we need to consider, because Felix might not start in Christchurch. He might start in Jakarta in Indonesia. And at that point, we run into a similar problem. Should we include that or exclude it? And at that point, we want to consider our filters. Do we consider, or do we just want to create a report for Australia, and then we include just Australia and everything else is just left out? Or do we consider New Zealand a very special place, which clearly it is? I'm sure everybody will agree to that. But we need to treat it slightly differently. All the other countries we can treat the same. New Zealand, we need a special report. In this case, we would exclude New Zealand. And then we deal with that automatically. Do that as early as possible. Consider what might happen and how you want to use it. Because if you set it up wrong once, you probably won't pick up on that until it's too late and you include the wrong countries. And one more thing of that is make it adapt. So that's a pattern that I see quite often. When it's Auckland or Wellington, then it's New Zealand. Otherwise, it's Australia. Again, that works great until we hire somebody in Christchurch, and then they are grouped as Australia as well. The solution to that is to put an explicit else in there. If there's anything that we haven't considered yet, call it undefined. If a user sees that in the dashboard, they will ask about that, and you know that, oh, the office is undefined, then I need to look at my calculation there and do something different. If you don't do it, it'll just be included in the data set. Nobody will pick up on that until it's too late, months down the track, when actually somebody figures that the numbers are wrong. So what I want you to do is to be thorough, think cases and account for them. Yeah, and there is a Wellington in Australia as well. That's a different story. So lastly, we have built everything and we want to make it as robust as we can. We get to try to test it by breaking it. We try to approach it like some of the good hackers. We want to find the flaws and expose them to fix them. We don't want to permanently damage something. If you can think of anything that could go wrong with your solution, chances are that it will happen at some point. The more users you have, the longer a dashboard is in use, the more likely it is that some of these things are going to happen. And if you did everything that I talked about, that should be quite easy. In fact, I usually don't do that kind of testing anymore, because everything I talk about here, I do it every time I develop. I think about these things from the beginning. But if that's something new for you, it might make sense to mock up a new data set, add in a new employee with a new city, add in a new year, and see what happens if your dashboard breaks or if it shows up as expected. If I think about testing, it's from two different directions. One is an upstream system, like a D database or an ETL tool that might do something unexpected. Or on the other side, what could your most inexperienced user do to get the complete opposite insight from what you have intended? So if we start with the upstream systems, you could have new data and that could break something. So in this particular case, we have 5 salespeople. I didn't realize here was that over the last 3 months, we hired another 5 Michaels. So that's not one Michael that is a great salesperson. That's actually 5 or 6 Michaels that sell a whole lot of stuff. And that comes back to names. Names are inherently vague, so do something else with it. Try to figure out what could happen if a value is duplicated, and how can you make sure that something is unique. In this case, you might have an employee number or a customer number that you can put in there that is unique. You can show it if you want to, but you don't have to. You can just hide the header in Tableau. Then you will see multiple rows for Michael. In that case, you probably don't know who is who, and you want to add a last name as well. But at least it's not all included in one. Another example, and the opposite, is something where you might have a year-to-date sales. Say you created in October, you have 10 nice bars, and that's all great. And then in January, you just have one big blue square in Tableau. And your user will call you up and tell you that your dashboard is broken, when in actually fact, it does exactly what you expected it to do, because there's only 1 month in the year for now. Try to figure out what you want to do with it. Do you want to scale it in a way that you just have one slim bar on the left side of your dashboard and then it fills up over the year? Do you want to include the last 12 months, that you always have 12 bars in there? Try to do something with it that your users don't think that your dashboard is broken when it really isn't. And then lastly, what happens if there's no data at all or a refresh fails? You can put the last refresh time or the maximum date of your data set in somewhere on your dashboard, so a user always knows how recent the data is. And if they just changed something in their CRM, and the dashboard says that the last refresh time was last night at 12 o'clock, they don't need to go to the dashboard and try to figure out why it's not there. They can clearly see, okay, it didn't refresh since I made the change, therefore I shouldn't expect the data in there. And then from the other side, what could a user do? And we usually what's a interesting thing, especially if you're not too experienced with Tableau yet, try to right-click on things and see what different options do. One of the things that Tableau does by default, and that really annoys me, is to have these include and exclude buttons in the tooltip, which means that people can accidentally exclude certain things or apply a filter without even realizing they do it. And not even to mention that somebody could do it with a bad intention. But it's really easy for users to just do it, not realize it. Again, take a screenshot, put it in the board pack, and before they know, the sales are lower than they expected. So you can deactivate it. On all my dashboards, I always go through at the end, deactivate that for all my tooltips. Similarly, for filters, there's an all option. In most cases, that's probably fine. But imagine you work in an international company that has sales in local currency. It doesn't make sense to add up New Zealand dollars, Australian dollars, Mexican pesos, and whatever other currency. So just remove it. There's an option there that removes the all option, and that makes sure that your users cannot choose that and actually get to the wrong conclusion. And lastly, especially if you work in larger organizations, load test your solutions in production, in a production-like environment, before you have, I don't know, hundreds and thousands of people hitting your dashboard. So make sure that your refreshes work in a production environment and it doesn't interfere with maybe other schedules that you have running at the same time, and give that some time. And when you roll it out, make sure that you're there to fix things and keep an eye on things, and don't just assume it'll work. So what I want you to do is to be proactive, realize that there's something that could break, and fix it, so that you or your colleagues don't have a lot of additional work in a couple of months. So in summary, you should be lazy. Don't do things repeatedly or things that are super cumbersome. Be thorough, cover all your bases, and think about what could happen and make your solution adapt to it. And be proactive. Find the flaws in your solution and fix them right there and then. I have a little bit of homework for you when you go back, depending on where you are later today, maybe tomorrow, maybe next week. Check one of your dashboards, maybe your most recent one. Check if you do if and case statements that don't catch your exceptions with an else, and make sure that they do. And have a look if your users can misuse filters. Can they include and exclude certain things? Do they have an all option in their filters when it doesn't make sense? And again, if you find that, please fix it right there and then, and don't wait until somebody does something wrong. And lastly, what I sort of figured out while creating this presentation, the whole thing, like applying best practice and saving yourself time further down the track, it's not just good practice. If you spend a little bit more time now to save yourself a lot of effort later on, And really, it's self-preservation. So thank you for that. I don't know if we have time, if there were any questions. Feel free to add me on LinkedIn, to get in touch on Blue Sky. The QR code, thank you, Chris, leads to my blog. You'll find a recording of the session. You find the slides. You also find the 3 blog posts that I promised that goes in a lot more detail of that.
Thank you so much, Alex. Great presentation and absolutely great tips to also look for solutions, not at just at one place, but at multiple places. And that's how you wrap it up in a whole solution. And the starting point of, I think it was torrent, right? That really evoked memories. Yeah. I remember downloading games and letting my PC just run for 3 days, and I would just wake up.
I've never done that.
I've done. So.
Never done that.
Okay, great. Let me check. Yeah, I know, Chris. Annabelle will take care of it.
That's why I'm not saying a word.
No, the audience doesn't have any question. Apparently, Alex, you were like very clear.
Or it was just too much to digest, who knows?
No, I really appreciate the tips that you gave, because definitely it was very useful. I mean, I remember with the year to date on the current year filter. So it's good to.
And like basically all of these things are mistakes that I've made myself. Like it's not like it's a common thing to not really think about that, especially in the beginning, until it comes back to bite you, and then you're like, yeah, okay, next time I should probably do things different.
Yeah, I implement the current year filters after 6 months, because they ask me, can you change now like all the filter on all the dashboard instead of 2018 to 2019? I said, maybe I should do something else about that.
Yeah.
Yeah, we learn by our mistake always.
That's right.
Okay, so moving on to the next. So now we have someone who looks the same as what his image is on the screen. So I'm just going to share his screen.
Thanks for that, Prasan.
Oops, I can't share my screen. Funny. Annabelle, can you try? Because I'm trying, but I can't share my screen.
So let me find. Yeah, I wanted also to say that I will check every single link that the speaker will give me. I will put it on the YouTube channel, and I will also put it on the email that you send. So please, speaker, send me all the information you need me to share. And yes, I should be able to share my screen. So you will see my infinity window, I suppose, in some. Yeah, partager, no.
Starting up another browser, it always happens.
It's okay, it's okay. Share, sorry, no share, no slideshow. I'm not fully awake yet. Up, almost here.
Cool.
Can you?
Thank you so much.
Yeah. Welcome.
Yeah, now I can see the screen. So now we have Joon Kim. As I said, he looks exactly the same as
He's
you can.
awesome.
Yeah, indeed. And June is a senior visualization specialist working for a retail organization in Australia, and he has experience in multiple domains, specifically in telecommunications and insurance industry. And he's a Tableau enthusiast who enjoys nothing more than helping others and help others understand data through visualization and collaborating with other community members. He outside of his time of work, and he helps answering questions on the Tableau community forums. Like, I think that's one of the greatest things anyone can go and contribute to the community, and I find it really hard. But on the other hand, it's helpful for me always to find some solutions. And so, thank you so much to everyone who is actually responding to the questions on forums. And also, apart from answering questions on forums, he likes to write blogs to share his new learnings and also participates as a co-lead for the Sydney Tableau user group. I think there's one more thing, it's not mentioned, but he also runs this coffee mornings in Sydney. That's a really interesting initiative, and I'll pass on to June to talk about his presentation, how to drive Tableau dashboards with user inputs, and also his initiatives. So thank you so much for sharing your knowledge with us today, June.
Thank you, Prasan. It's such a great honor to be presenting at the Analytics TUG once again. Um, let me see if I can get the tech working. So let me see if I can share my screen
And I
first.
will be very interested to hear about your coffee, your coffee initiative too.
If there's time, I'll definitely cover that. I'll do an advert. Okay, so I have to make sure that I'm actually pointing to the right screen. Okay. 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 So before I get started, I just want to say that it is such a humbling experience every time I'm in the within the audience of people who are obviously a lot more skilled than I am, and those who are obviously contributing a lot more to the community than I do. So it is always such a humbling experience on my part to be even given this opportunity to talk about this little thing that I happen to have discovered along the way. But I hope the audience will find this information useful, as I certainly have in my role. So today's topic is going to be about how we can build Tableau dashboards to accommodate user inputs. Now, on the surface of it, it might sound like, okay, well, isn't that what we already do? But please do allow me to go through the rest of the slides. We have a long slide, but I'll try and make sure that I go through them quickly enough so that people aren't going to be bored. Um, and how I came across or stumbled across, I suppose, this problem initially is just one day I was speaking to one of my colleagues at work who has spoken to one of our stakeholders who asked a question on, can we do something like this on a Tableau dashboard? So we were discussing this problem, and within a matter of a few minutes, we both made a conclusion that dashboards are not supposed to do that. And that evening, as I was lying in bed counting sheep, I just had this idea that maybe I could get this work. Obviously, I didn't have an answer at the time, but I just had this feeling that, okay, well, maybe I could try this and this could get it to work. And then this is how the whole thing actually started, and then subsequently became today's presentation. So I'm super excited to be sharing this little tip with you that would hopefully give you a slightly different perspective on how we see dashboards. Okay, so with that said, I guess the first big question that I'd like to ask the audience here, the first one right off the bat is, do you think that dashboards are supposed to be read-only product? Up until recently, I certainly thought so. But please don't take my word for it, because as we live in the age of AI, I decided to ask a very good friend of mine, Gemini, to come up with a definition of what a dashboard is. And it gave me about dozens of different sentences, which all kind of pointed to the fact that dashboards are really a one-way street where we are actually reading, extracting information from it. But nowhere did it mention anything about us having the, I guess, the ability to ingest information back into the dashboard. So a lot of the common terms that that I came across were, it's a document that presents complex data. It uncovers things, and it also reports on performance or progress, and a whole lot of other things along those lines. But my take on this and my thoughts around this is, yes, while this might be true most of the time, I think it also boils down to how we choose to use dashboards, to design them and then to use them. So I guess there's two answers to this question. I think it's both a yes and a no. But I guess we'll find out a little bit more about the audience would perceive this. Okay, so on that note, with that in mind, what if I said we could build a Tableau dashboard that could take multiple concurrent user inputs without leaving the dashboard, of course. And if you were able to achieve that, what are some of the potential benefits that we can get from that capability? I've kind of summarized it into 3 bullet points there. I'm sure there's a lot more extending way past those 3 bullet points, but the ones that kind of popped up in my mind were things like we give the power to the users to build hypotheses on the fly while they are viewing the dashboard, which of course then potentially negates the need to build that beautiful download button in one corner of your dashboard, which I'm sure a lot of you tend to grown quite fond of, because obviously it means that there are certain part of that dashboard where you don't necessarily need to do further manipulation of the data because of the fact that we are able to ingest data straight into it. And that then leads us on to that 3rd bullet point, which I think is what really represents the value for the business users. And it's the fact that you're able to build your hypothesis within the dashboard itself, meaning that you can reach the decisions a lot faster. So what I choose to do for the rest of this presentation is to use an example, a bit of a story around this, so that we can try and contextualize this as we go along. So our favorite store, the Superstore, the team at this store actually needs a Tableau dashboard that will allow them to ingest different customer numbers for any select number of cities. Obviously, in this instance, it's within the confines of those 5 cities. And then to be able to generate a revised sales projection, which is that last column highlighted in yellow. So just to quickly summarize what the crosstab contains. So based on those 5 cities, each of which we have the total sales amount. We also have with that the total number of customers who happen to be shopping within that region. And between those 2 numbers, we can obviously work out what the average sales per customer is going to be. And then what we are trying to determine is based on the change of, I suppose, a population change as far as the story goes within each one of those cities. Based on that population change, what would be the revised total sales? And what we are trying to do is not apply the variance to all the cities in that list, but be able to selectively choose the city to which you'd like to assign a new variance. So with that said, I'm going to first dive right into a quick demo of a dashboard that I built for this presentation. And then once we've seen what it is, then we'll come back and discuss the how part of that. Okay, so let me just switch over to this other screen. I did publish this on Tableau Public. So I hope it's as easy as just sliding this across. Did that work, Annabelle? Sorry.
Yes, it worked. Yeah, I
Okay,
could see like your Tableau public.
okay, I'm struggling a little bit here. Okay, okay, so this is the dashboard that I built that would help to solve this business problem that Superstore management team has. And in this particular view, I know it's a little bit more than 5 cities in the list, but I guess the underlying principle is going to be the same. So what I wanted to show you was, I won't go into the nitty-gritty details of what's really behind this particular dashboard, but just to show you what it is possible of achieving. So we've got a list of these city names, and I'm going to select any one of these cities at random. So I might just choose Freeport. So I've chosen Freeport. And then we have this field where we can enter the variance. So at the moment, we can see that for the city of Freeport, the customer count is 4. So I'll say, I think the city will increase customer count by a factor of 2. Apply. And then if you just go across that row, you'll find that initially the customer count was 4. But now we can see that the customer number has been revised to 6 because we've simply taken the 2 and added it to the 4 to give us the 6. And subsequently, that would then recalculate the revised sales, which happens to be the $131 per customer multiplied by the revised customer count. It doesn't stop there. Obviously, if it did stop there, then it wouldn't be a good tip worthwhile sharing with the audience. So what gets interesting is with the subsequent selections. I might choose Jamestown next. And then if it did, you'll notice that the variance of 2 that we had previously assigned to Freeport actually remains. We're going to try something a little bit different. So we've got 2 customers. Actually, no, sorry, I changed my mind. So let's go with a higher number. So we'll get 11. And then we can then see that logic propagate through to this particular row as well, where previously we had 2 customers plus 11. That gives a total of 13. And here's your revised sales number. We're going to try one more. Target this particular city, which has a relatively larger number of customers of 22. So we'll select that. And then this time, I think there'll be a population reduction in the city. So I'll do -1, apply, and then there you have it. So it's gone from a population of 22 down to 21. And as you would have guessed it, the total revised sales would be showing a reduction from its original value. And there's the reset button. Okay, so that was a quick demo on how that solution is supposed to work. So I'll now come back to our slide pack. Okay. And now that we've seen this, one thing is going to be blaringly obvious, and it is the fact that one of the major pillars behind this solution is actually a parameter, which happens to be one of my absolute favorite features of Tableau among so many. I'm sure it is for many others in the audience here today as well. Okay, so we know that we are using a parameter for enabling user inputs. So we use it as a free text field currently, as you would have seen in that demo. But I guess the question here to ask is, and this is also a question for the audience here too. So if we have hypothetically a crosstab such as the one that you see in the slide now with 5 cities, and if we wanted to be able to at random assign variance to any one of those or any multiples of those cities at random, then on one hand we could think, okay, well, if we did have a parameter for each of the cities, that will work. I certainly think so. But then that kind of leads on to a problem. And the problem is that solution or is that type of approach going to be scalable? So hypothetically, what if we had a crosstab of not 5 cities, but if we had 20 cities? Would you then be motivated to go and build 20 different parameters? So that's certainly something to think about. Or on the opposite end of that extreme, what if you cut everything down to bare minimum and decided that we could run with one parameter? Is that going to work? And we're going to just use this really simple demo to illustrate what the problem might be. So let's say that a user decides to introduce a variance of +1 for the city of Auburn, and subsequently you have the revised sales, which is correct. That's fine. But what happens if we wanted to reuse that parameter for a second city selection? So this time we're going to choose Freeport. And this time we want to introduce a variance of not +1, but +2. So that does a great job of calculating the correct revised sales for Freeport. But at the same time, Auburn is kind of left out of that loop because the variance of 1 that was originally assigned to Auburn will not stick. So this is going to be the consequence of running with a single parameter. And that's to say, single parameter, again, is only capable of holding a single value at any one point in time. And that is up until now. So we'll then move on to a little quiz, which I'm not going to answer right now, but a little quiz that I'm going to leave with you, with everyone in the audience. Before we see the final breakdown of how all this works, I'd like to ask a question of how many parameters in total do you think it would take to drive that solution we've just seen in the demo? So you don't have to answer that now, just keep that in your mind, and then we'll subsequently get to that answer relatively shortly. Okay, so this one might actually sound a little bit out of the left field because all of a sudden, Joon's talking about an array, but I felt it was pretty important to introduce this concept at this part of the presentation. Now, I'll come back to that point a little bit later. But firstly, I'm sure that everyone in the audience has a good comprehension of what an array is. In a programming context, an array is considered to be like a temporary storage space where you can put bits and pieces of information in, only to have it retrieved later on as they are required. And that's exactly what you're seeing in that little diagram, where you've got little packets of information going in, and then it's coming out the other end. Now, and then you see this little gentleman here saying, why is this information relevant? Well, I'll say it's relevant because how that solution works kind of leans a lot into the concept of how array works in a programming language. But while we cannot replicate it in exactly the same manner in Tableau as it would in let's say, a typical programming language. But what we are trying to do is we're going to borrow on that idea of being able to store multiple bits of information into this temporary storage space and then calling upon it as we progress through the workflow. And we're going to do that using parameters. So we're going to then, actually, before we go into to breaking down what and how the parameters are actually used to giving us that capability, just like to pause here for a moment just to do a quick fact check on what a parameter is and what it is capable of doing. So number one, that's an obvious one. A parameter can take only a single value at a time. So just hold on to that thought. That's going to serve us quite well. Fact number two, and I think this is also equally important. Have a think about what it is that we are pushing into parameter, and also have a think about how fact number one, that's clearly beyond our control. That's just part of the system, so we can only take one single value. But where we do have a control over is our ability to dictate what we push into the parameter, and that's where the true magic lies in this solution. So my 2 cents worth here is on that second point. If we can carefully have a think about how we're going to plan the the transfer of the data into a parameter, and the emphasis is on the how, then we could literally replicate the function of an array within this domain. And I'm going to show you how. Okay, and this is where we're going to do a little bit more of a deep dive on understanding what the actual anatomy is behind this solution. And what I will do is, rather than diving right into the great depth of the Mariana Trench, we're going to go from the top level at a very high level, what it looks like, and then we're going to gradually go down into the finer details of the mechanism. Okay, so we're going to start with the bird's eye view of what this design actually looks like. So we have the crosstab. It's the same crosstab that we've seen before. And through a number of user interactions with the crosstab, we then store the required information into the arrays, or I'm going to use the term interchangeably here, arrays or parameters. And then once the information is within those parameters, then there is the other step of trying to build, I guess, a relationship between the city and the variance, because there is going to be a matching pair. And once we've established that matching, then we are able to then determine exactly on which row of the crosstab that we can assign that particular variance. Okay, so that's enough said on this slide, but I'm going to spend the next few slides sharing with you rather a very crude animation on how this would actually look like, or how the motion that we've seen in the demo, how that can be described using these set of graphics. So first of all, we have on the crosstab a city of Auburn being selected, and that would initiate a push of that city name into parameter number 1, which of course is dedicated for city selections. And subsequently, the user is required to then key in the variance for the city of Auburn, and that information makes its way into the second array, or parameter number 2. And that completes the first cycle. And for the second cycle, we go and interact with another city. This time it's Freeport. Same deal. City number 2 makes its way into parameter, and then subsequently the variance also is registered in parameter 2 once again. So we've got in total about 3 cycles for the purpose of this illustration. But what we're now going to do, because now that we've actually seen the operation of this, we're going to spend a little bit more time looking at each of the components and what really happened in each one of those interactions. Okay, so the first one's going to be an obvious one. How we actually managed to get the information off the crosstab and into those arrays. Starting with the city is simply a parameter action. So it would select the entire row of information, but within that row, we can dictate which column that we extract the information from. And it basically just takes that information and then passes it, pushes it into the array. Easy. Now, when it comes to the variance, it's a little bit more involved, because the key difference here is that you actually need the user to key in a number into that field. And once that number has been registered, we need some kind of a trigger to then transfer that number into parameter number 2. Now, I know I did apply a button to go with each one of those variance inputs, but please don't think that that's the only way that we can achieve the same outcome. We could have actually made it a little bit more subtle rather than having a button next to it. But that's really going to be up to the designer on how they would like to make the dashboard look and feel. Okay, so that's how variance is then pushed into parameter number 2. Now, what hasn't been covered here is the fact that there is something that's a little bit more involving in having to go from a parameter that contains one city name to multiple city names. But the logic that's used for that is going to be revealed in the following slides. But before we go there, just coming back to the original quiz that I had put out there for the audience. I hope most of you got this right, because it's now quite obvious that it takes 3 parameters to build a solution, which is better than 5 or 20. Okay, so the next part of this flow involves extracting that information out from the arrays, because we've covered the part where we're pushing the information into the arrays, but we will also need to be able to pull the information from those arrays so that we can populate the correct rows with the right variance numbers. So the question is, how do we go about doing it? We've got 2 storage units, but the big problem that we do have here with parameters is, unlike the native arrays, there is no means of having an index. So we cannot simply point to a piece of information in any one of those parameters to say, yes, I want that one. I want number 2 or number 3. So which is going to be the key difference between a native array and the parameters, which then has a follow-on problem. Because we're unable to index certain bits of those information, we're also unable to build, I suppose, associate any city with the corresponding variance, as you can see in this particular image. So that's going to be one of our hurdles. We'll get to how we actually get around that problem. But before we do, I just wanted to just do another quick reveal of what really goes on behind the scenes as we are selecting multiple cities. So up until now, a lot of my illustration has been a gray pipe with separate city names sitting inside it, like nicely separated out, and then they're quite distinct. Whereas the way Tableau looks at it is, it's not 3 separate cities. So if it was Auburn City 1, Freeport City 2, and then Hempstead City 3, parameter will actually read it as Auburn, Freeport, Hempstead. It's a concatenation of those 3 sets of strings put together. Hence, that explains the reason why there is no concept of indexing. And remember what we said before about how a parameter can only contain one single value at a time. So those 3 cities that you see on the left-hand side of the equal sign, they're not actually 3 bits of information, but it's actually one big chunk of information within which we have concatenation of those 3 city names. Now that we know this, if we go back to the process of having to push an additional city name into a parameter, so in this particular instance, if we have city 1 and city 2, that's already in the parameter, and we're having to push city number 3 into that same place. What's effectively happening is, we're not just going and adding that last city name into an existing lot. We're basically emptying out the parameter that's currently a concatenation of the 2 cities, and then replace the whole unit with one other big chunk of data that now contains a concatenation of those 3 city names. And hence that still retains that principle of parameter containing one single value at any one point in time. Okay, now that we've got that out of the way, here is my take on how we would artificially embed index into the parameters. And one way we can go about doing this is to assign an index number as part of the payload. So in this instance, we're going to be applying that to the city parameter. And you can see in the blown up image that we are putting the number in front of the city name. Okay, so this is really going to be the deep dive part of the presentation. And this is also the part that really gets me excited. Okay, so we're going to be covering 2 cycles. I know in our example we've covered 3 cities and then the corresponding variants, but the second and the third one is basically going to be a repetition. But it would be important to understand how it goes from the first cycle and then to the second cycle. And once we know that, then we basically covered all grounds as far as this solution is concerned. So we're starting from ground zero. So parameter number 1 for city selection is empty. And actually, I need to actually mention this. I know there is. It seemingly looks like it's the click action on the city row that takes place first, but in fact, there's something else that actually has to happen prior to that, and that is the so-called index generator. And what index generator does is it produces a number that needs to be accompanying the city name, which will in combination end up into a parameter. So to do that, this is what we do. So we actually check through the list of city names in that cross tab that you see in the middle. So what we're effectively doing is we're actually checking to see if the parameter number 1 contains any one of those cities. And obviously with a blank parameter, it's all going to be returning a null value. None of them actually exist in the parameter yet. And then what we do is we do a count distinct of that second column, which will comprise of null, which would obviously then return a value of 0. But I don't want my index to start at 0. So I increment it by 1. So our first official index becomes 1. And then comes the interaction where a user would select Auburn. And this time, rather than just pushing Auburn directly into the parameter, what we're going to do is we're going to turn that index into a string. We're going to concatenate it with the city name. And then we're going to end it with concatenation of a comma, more or less a delimiter. And then hence the revised diagram you see there, you see the number 1, Auburn, and then followed by a comma. And then comes the next part, variance, and this shouldn't be a surprise to anyone, but it's worth highlighting the fact that with this example, once that variance is entered and passed to the parameter, note that it's not just the number 1 that ends up in the variance parameter, but you can actually see a comma that follows behind it as well. And this is going to be quite important as well. Now that we've got those 2 bits of information in those 2 parameters, it's now time to then try and marry up those two parts so that we can then use that to assign the variance to the right row. So what we do here is we go through that list once again, and we check that against the city selection parameter. And in that parameter, we check to see if any one of those cities actually resides in it. So Auburn obviously does now. And once we do, what we wanted to do is we want to then execute a string function. There's a string function called find. So what we're looking for is the position number within that parameter upon which that city name starts. So we can see that Auburn with an A starts in position number 2 because there's nothing else that precedes Auburn in that parameter there at the moment. So it's number 2. And once we determine what that position number is, what we're going to do is we're going to take that number and then we're going to extract. Once again, we're using a string calculation here to say, give me everything to the left of position number 2. In our case, it'll extract a value of 1. And where that 1 becomes important is we then take that number 1 and then we go to parameter number 2 and say, hey, can you find me where the first comma appears? And that first comes from the fact that we've extracted number 1 from Auburn. So it goes and finds the first comma, for which there's only 1, and then it does an extraction of the value that sits to the left of that comma. And voila, we have that number that's ready to be assigned to that particular row for City of Auburn. We're now going to go through the same motion with a second cycle, meaning that we'll select a secondary city. So starting with, once again, the index generator, we're looking at a parameter that contains Auburn. So we'll do a check to see if any one of those cities in that crosstab actually resides in the parameter. And in this time, we do have Auburn. So it'll return the city name, Auburn, in that second column. And from there, we do a count distinct, for which it returns a result of 1. We're also going to increment that by another 1 to give us an official index of 2. And writing off the same principle as before, we're going to be appending that number 2 to the second city that we select, whether it be Buffalo, Freeport, Hempstead, or any one of those cities. But it's going to be a little bit different this time, because what we do need to do is make sure that we are not overriding the existing value in parameter number 1, because remember, we've got number 1 Auburn sitting in that space. So what we want to do is we want to concatenate everything, including Auburn, so that we are retaining the first selection and basically appending the second selection to that. So it's going to be 1 Auburn plus the index plus Freeport plus the delimiter. And there you have it. And that's why parameter 1 looks like what it is in the image. The same deal goes for the variance of it. So for the city of Freeport, it's a variance of -1. And as you can see, it's going to be, and I did actually make a mistake here. Sorry, I do apologize for that. The comma for the first variance was already there, so I didn't really need to mention that. But it's basically 1, which was the first variance, concatenated by the value -1, followed by the second comma. Okay, so the second set of values are filled those 2 parameters now. And then we are now back to that process where we are having to check to see if that city actually lives in the parameter. And in the case of both Auburn and Freeport, they both do. So at this point, what's actually happening is it's actually performing a calculation across both cities, not just Freeport, so that Auburn will continue to get variance of 1, and then Freeport will basically get its corresponding variance 1. But once again, what it's doing is it's counting the position of where Freeport starts. And I hope this illustration, this zoomed in illustration is clear enough for the audience. But starting from 1 Auburn, comma, as you actually progress through that, Freeport actually happens to start in position number 10. So we take that number 10, and this time we are not saying give me everything to the left of position number 10, because remember, there's Auburn in front of 2 Freeport as well. So we need to make sure that we are going left first, and we're going to encapsulate that calculation in another string calculation to say, give me everything to the, give me the last digit or last 2 digits to the right of the extracted string, and then we're basically just ripping out the index number from Freeport, which is 2. And once again, we take that number 2 and we go to parameter number 2 and say, okay, find me the position of the second comma in parameter 2. And then from there, we're going to go left first, but recognizing that there is another preceding value in terms of variance. We're also going to make sure that it's also a number that happens to be sitting to the right side of the previous comma. And then we then extract the value of -1, which gets then pushed into that particular row for City of Freeport. So that pretty much wraps up the details on how this solution works. I hope the audience found that useful. Now, if you'd like to have a look at how this is actually put together in Tableau Desktop, then you know that it is available on my Tableau public profile. So please feel free to download it and break it if you can, and do let me know if you do break it. But yeah, it's going to be available in the form of the Tableau public document. But I'm also very close to finishing a blog for this as well. So please do connect with me on LinkedIn. as I do from time to time publish these documents there as well. Just before I go, I know I've been speaking too much, but just before I go, I thought I'd just throw this slide in there because I just felt it resonated so much with what we do as DataFam. Now, Don Walsh, I didn't know who Don Walsh was, but I happen to have just come across his quote as I was putting this slide together. So Don Walsh apparently was the very first person back in '96 to have dived into the great depth of the Mariana Trench. So he's to this day he's praised as a true explorer. But as I was working through this problem, I kind of thought, aren't a DataFam also an explorers in their own right? Because we're obviously driven by curiosity, our inquisitive nature to go and try different things in Tableau, and then boom, you come up with something new. But that only happens when you mix curiosity and physically putting that into action to just do, not think too much, but just to do, and then you'll be surprised at what you can discover and explore. So I guess this was kind of reminded to me to always stay curious, stay inquisitive, and then don't hesitate, but always try and do, then just to think, and that's when the true magic really happens. So with that, thank you so much for your time. We do really appreciate your patience. Yeah, and that's a wrap for me. Thank you.
Thank you so much, June. And that was an interesting use case, to be honest, and how you're leveraging it using finding and then indexing it. I think most of the users would like to go back to the video and then again rewatch it so that they can implement it. But thank you so much for sharing your use case and the whole process and the thought behind it, how you actually solved that problem. So
Thank you so much.
it was really interesting to see.
I
Annabelle,
really
you're on
love
mute.
your presentation. It was very cool. Thank you.
Yeah.
And as soon as you finish your blog post and you have the link, I will also put it everywhere.
Cool. So, yeah, I think everyone's processing and they would like to go back to the video and then they might come back to you for more questions, June. So be ready for that. And thank you so much for that smile as well that you're having while you're presenting. So that means a lot. Okay, so now over to our last speaker of the day, a person who runs, I think I shouldn't say new, but an interesting tug that's called DataFam tug, and he has been doing this series of all the events that happen at Tableau conference and back to back. Is it like every week? Not every week, or it's on consecutive days or something, right?
my general guide was one a week, but this week it's tomorrow and next week Monday. So that's 2 tugs in 4 days. But they're really little ones. They're nothing like this. It's 20 minutes or 40 minutes or something. So,
but still, like doing it every like even 2 days in a week, that's a huge commitment. So thank you so much, Chris, for doing this and also bring this whole all different tugs on a single YouTube channel. That's really great. Okay, so I think I'll try sharing my screen again and see if I can. Viraj is saying that's easy for Chris. Annabelle, you need to help me again.
Sorry, what happened? I just grabbed a glass of water. Ah, yes, you want me to share the screen.
Yes.
Well, I don't.
Next time I'm going to use Chrome, no Safari.
It's okay. It's okay. I will just do it. Let me time to rise. Yes. Full screen. Infinity window. Alors, slide show. Et voilà.
Yeah. So we don't have that much information on Chris, and we would like him to talk about himself more.
We need some fun
However-
fact.
Exactly.
Oh, what's a fun
So
fact?
that will leave it to you, Chris. So if you are not following him on LinkedIn, you can search his keyword CMCAU and do it on Twitter. He's a 5 times Tableau ambassador. He's based in Sydney, and he's a freelance consultant that works virtually around the world, helping anyone with data engineering, modeling, and visualization, more like end-to-end solution. And today he's going to talk about not just Tableau, but from warehouse to dashboard, how you can leverage Snowflake, dbt, and Tableau in your workflow and then build a solution. So I won't take much of your time and hand over to Chris now.
Awesome. I think the fun fact, now that you've dropped me in it, is I think when I first started using Tableau was in late 2014, and when we were using software back then, it's like a new version would take a long time to come out. So I downloaded Tableau 8.2, I think, and within a few weeks, 8.3 came out, and I went, but 8.1 was earlier this year, and then 8.2 and 8.3. It's just like, this software is crazy when you just get new versions all the time. It's, that's just a new concept. And obviously that's, my other jokes when I teach Tableau sometimes is I had a student in my class one time, he said, how long has it taken you to learn Tableau? And I said, I've been learning Tableau for 10 years. And he's like, my God, it's so hard to learn. And I went, no, it's not hard to learn. It's hard to keep up with all the new features that come out every few months. So I said, when level of detail first came out, or when all these features come out that you've got to keep up with and you've got to keep current with. So you can do things like what Joon was doing, or, dynamic zone visibility, on all these things that come out all the time. Map layers is the latest trend of everything's a map layer, because go back 3 years ago and try and do things in map layers, it's just impossible, because it basically wasn't in the product then. So as Joon said, you learn all the time, and you never stop learning. Keep on doing things, keep on talking to the community, and it will just push your ideas and your concepts in a different way. And this session came out of a talk I had with Annabelle, I don't know, maybe about 6 or 8 months ago, of just before the dashboard, what has to happen. So we came up with this concept of from warehouse to dashboard, and purely talking about what is Snowflake? What does it do? What is dbt? What is Tableau? We all know what Tableau is, right? So even on this agenda, Tableau, there's a tiny little bit of Tableau right at the end. And again, as the other presenters have said, thank you for the time to present, and it's really a privilege presenting to this TUG as well. And obviously, almost like what Alex did and what Joon did, I've got a lot of slides. I don't have a lot of demo, and hopefully with those slides, you'll be able to see how this works. And one of the call to actions you'll see along the way is go and play with it yourself. Right? The software is fundamentally free, almost like Tableau Public. Is download the software, learn how to use it, go and ask people questions. People will be wanting to talk to you about this. And again, questions in the chat. Hopefully we'll have time at the end. I'm looking at my clock to make sure I get finished on time as well. So to look at what we mean by this whole warehouse to dashboard first is the overview of, there's a thing called the modern data stack. And again, I've got some slides which have got a lot of words on them. I'm not going to read the words, they're for people to read later on. But the modern data stack is this concept that things are going to be cloud native. We use ELT, not ETL. So the data is loaded directly into the warehouse, and then we do things with it. And again, all these terms, if you don't know what those terms are, I'll cover them through the presentation. But ETL is almost like the old way of loading data. We extract, we transform, and then we load. And these days we use ELT. We extract and load, and then transform at the end, which is what this slide's showing. So a modern data stack, again, looking at it a different way. We've got, I don't care what source systems you use. I don't care where the data's coming from. From a modern data stack point of view, we don't care how it's ingested, but it will end up on a storage layer. and then we transform that data into Tableau. Now, there's a lot of icons there. These are all different products that do those different things. So your source systems are going to be different. Your ingestion system might be one of those pieces of software. It might be something else. You know, Enrique's already saying in the chat that Salesforce bought Informatica today, or in the last few days. Your storage system, I don't really care what storage you use. I would always say use a database. You know, use some sort of relational SQL type database. Don't use Excel. Excel's nice for learning how to use Tableau. It shouldn't be your database of choice for using Tableau. And then obviously we've got a variety or a lot of different options in our transformation layer before we get into Tableau. But my preferred MDS or my modern data stack is this, and this is what most of the presentation's on today. Again, what's your source system? I don't know, could be anything. It actually doesn't matter, but we need to know what those systems are. And in a big Tableau environment, you're going to have data coming from a lot of sources. We ingest the data through, my favorites at the moment is probably a mixture between Hevo and Airbyte, and land that data into Snowflake, do the transformations in dbt, and obviously all the analytics happens in Tableau. So what's Snowflake? Because that's going to be most of the main, obviously we're concentrating on both Snowflake and Tableau through this presentation. Snowflake's a cloud database. It's storage capacity independently from processing power. I'll explain that in a minute. And structured and semi-structured data. Basically, it's a cloud database that you only pay for what you, and it uses SQL as its main engine, and it's got a lot of power to do a lot of different things. Ultimately, what a lot of companies have found around the world, and companies as well, is Snowflake offers all the functionality that you would need in a database. We've got the centralized storage, and as in the core, and that we can do our loading, our ad hoc analytics, any development that we might do, because it does a whole heap of AI and machine learning and things that we're not going to talk about. And then around the boundary, we've got security, we've got our metadata, we've got our database management, everything that you can do. Again, instantly and automatically scalable and elastic. So in that mean, I break it down to saying it's like using a taxi or like using Uber. When you get in the fee, you start paying for it. When you get to the end of the trip and you get out of the taxi, or if you get out of you stop paying for it. You've only paid for your usage when you want to use it. It's not on 24/7. It's not, you shouldn't be paying when you don't want to use it. You pay for just what you're using. And that cost of Snowflake, which this I'm hoping to break down, and I'll walk you through this slide in a minute, but a lot of people have problems with the cost of Snowflake. It's really pretty simple, even though there's a lot of numbers to process here. But the simple thing is, on the left, you have to choose an edition to start with. People don't know what edition is best for them. I'd actually say Enterprise is the best. Standard has some base features. Enterprise has a lot of things, and the most important I called out here is the 90-day time travel. And time travel means I can make a mistake in my database and just point back to an exact timestamp, which also means that because it's Thursday night and I realize that the Monday didn't load properly, I can just issue a command and go back to Sunday because the Monday data didn't load properly. So that's one of the features of Enterprise. Enterprise also has row level security and column level security. So in the database, you can say, can users actually see these records or can they see these columns? And then a step up from there is business critical. It costs more to do that. And a step up from there is virtual private Snowflake. So again, there's 4 different editions. Most people use Enterprise because that's the best choice and balance of features. Once you've chosen your edition, the costs change. So Snowflake always talks in terms of credits. So a credit, if I'm running on an AWS Sydney-based Snowflake, my credit costs me $4.05 US. I'm in Zurich, it's $4.65 US. Or if I'm GCP in Iowa, it's going to cost me $3. So again, once you've chosen the edition and you know what edition you're using, and you've chosen the location, you'll get that credit cost. For ease, I've just, another step before we get there. And then we've got to choose what our virtual warehouse is. So a virtual warehouse is a t-shirt size. It's basically how much power the machine has. So if you go from an extra small all the way up to a 6XL in different steps, it costs you different credits per hour. And the easy maths is just, so if I'm on AWS in Sydney at 405 a credit, if I'm using a small warehouse, that costs two credits an hour. If I run that warehouse for exactly 1 hour, it's going to cost me $8.10 for an hour, or $16.20 for $2, or the maths is easy, right? But you're never using a warehouse for an hour or 2 hours or 3 hours. Sometimes you can use a warehouse for 2 or 3 seconds and turn it off. So Snowflake usually calculates at the per second rate. And it's harder to do those maths here. But if you looked at that, you might say Snowflake's very expensive to run. If I'm using it for 4 hours, it costs me $32. For some of my clients, 4 hours of thing might be spread over 7 or 10 days or something as well. Okay, so you wouldn't use it all the time. And also in Snowflake, there's a concept of an auto suspend. So if you are using Snowflake and you happen to get a phone call or go off to a meeting or even go to get a drink of water or something, Snowflake can put itself to sleep. And as soon as it goes to sleep, you stop paying for that cost as well. So it really is quite cost effective. And again, I've got quite a few clients who work under some fairly tight budgets on their Snowflake costs, and they're fairly happy. And if those costs even increase over time and we say it's getting a little bit too much, we can come back and investigate and tune Snowflake to actually work better. And that's possibly, even in one case, we went from a small up to a medium. And if you look at this, so a small to a medium cost me twice as much. I'm now using 4 credits per hour for my medium, where I was using 2 credits per hour for my small. But increasing the warehouse size actually saved us money because the processing can happen twice as quick. So then if we say, if a small runs for 10 minutes, maybe on a medium it can do the same job in 5 minutes. That would be the same cost. And if it can do it in less than 5 minutes, we're actually saving money using a more expensive warehouse to do that processing. And storage, again, it depends on your location, it depends on your contract, but you get charged in the number of terabytes of data you're storing in Snowflake. A lot of people don't have terabytes of data, but obviously in some fairly large enterprises, you would have, you know, hundreds or thousands of terabytes of data. I know there's some Tableau people that probably most of us know that have worked at Tableau and Snowflake, and they work on petabyte size tables. But again, Snowflake is elastic. As much data as you want to put in, it will work. As much money as you need to actually process that, or what your processing times need to be, you can do that as well. Heather mentions tariffs. I don't know what tariffs are. The US tariffs, I don't think it comes into it. Donald Trump doesn't know about Snowflake at the moment.
I think it was a joke because I said, I don't understand why it's more expensive in Zurich than in Sydney. It's like there is no human behind.
So it was only when I was doing the research for this, it used to just be, I actually thought it was $4.05 everywhere. And the more I looked, I peeled out a few examples for hopefully people attending tonight. And it was depending on your platform. So it can be AWS or Azure or GCP. And there's now a lot of different data centers around the world, and the cost just changes all the time. So yes, if you weren't worried about data sovereignty, or sorry, if I was worried about data sovereignty and I was living in Australia, I'd use Sydney, and maybe not AWS, but a few other different platforms. If I was worried about data sovereignty, I wouldn't have my data in the US, in Iowa, to save that $1.05. But if I am really cost conscious, and I don't care where my data really is, and if I wanted to be on the other side of the world in Iowa, $3 might be attractive. All I'm saying is that when you're actually setting up the account, when you're setting up your first Snowflake account, you need to choose the edition first, and that just applies those prices as well. So if I was using standard, the prices might be a little bit cheaper, but I've got less features. If I'm using business critical, I've got a lot more features. I can use things like private link, I can be HIPAA compliant, all those sort of things, but the credit cost is more. And then this table always stays the same. That's the number of credits per hour, because we're not talking about dollars anymore. We've turned the whole logic into Snowflake credits, the same as a lot of games and different things do. What is a credit? Well, we've already converted our cash into credit, so it doesn't matter anymore. And then we do that calculation there. Again, I don't think I've got any clients that use even 1 terabyte of data. We might be using gigabytes. It might feel like we're using a lot of data. I've got several clients with tables, they've got database tables with hundreds of millions of records in the table, and that might be a few gigabytes. I don't have any clients that go to a terabyte. But as I said, I know sites around the world that use petabytes of information, which is thousands of terabytes, I think, if we've got that right. Any questions? That's good. If there's any questions, just keep on going in the chat. So that's about as much as we need to know of Snowflake. It's just a cloud database that we pay for what we use, and we could just live quite happily in Snowflake and do a whole heap of things just in Snowflake, just using SQL. But then DBT is this thing that came along, and DBT, a hot tip with D, it's always lowercase. DBT means data build tool. Always use lowercase, because that's just one of the jokes with DBT. If you search for DBT uppercase, that's something completely different. This DBT tool is always lowercase. Again, DBT, data build tool. We're coming back to look at ELT processing again. So extract it from a source system, load it in the Snowflake, and then transform it at the end. DBT will only do the T part of ELT. So I'll say that a different way. That means that for DBT to work, the data's already got to be in Snowflake, and it will only transform the data and put it back into Snowflake, okay? Or whatever database you choose. But DBT, both the source and the target are the same database. It can't move data in, it can't move data out. It offers a lot of cool things like version control. So as Alex was saying, if you make a mistake in your code, if you make a mistake in your Tableau workbook and you save it, how do you go back to your old Tableau workbook? How do I get to the code that I had this morning? DBT has version control. So it will remember every single change you ever make to your code that's stored in GitHub. We'll talk about that later on. So I can go back to any version of any change I've ever made in DBT. It's all stored in GitHub. It's also modular, so I'm not working with a big piece of code. I should have tiny little models. I'll tell you what a model means in a minute. We can apply testing to that, and we can automatically generate our documentation. The key to using DBT is we're writing in SQL, and we're writing select commands, or select statements, as it says here. If you don't like SQL, now's the time to learn, because Snowflake is a SQL-based database, and DBT, you're always writing SQL as well. And DBT comes in 2 flavors. There's the core version of DBT, not like Tableau Core. This is a little bit different. DBT Core is free, open source, what they call FOSS software. So free and open source under the Apache 2 license, which means you can download the source code, you can install it on your own hardware, you can do whatever you feel like doing with it. It's free. The DBT Labs, which is the company behind it, keep the source code updated. They keep you on relatively the latest version, and you can just host it yourself and use it forever for whatever you need to do. Like a lot of other open source software. You know, WordPress is the same thing, because I think Alex was saying that he's got a WordPress site, or there was someone talking about WordPress before. And it's also Docker compatible. So if you understand all that stuff and you wanted to self-host it, DBT Core is the product for you. DBT Cloud is a slightly different product. And again, because we've got a Tableau audience, this is a lot like Tableau Cloud. It is fully managed and hosted by DBT Labs. So like Tableau Cloud, you log into a website, it's fully maintained and updated by the vendor. We've got the IDE, we've got all the latest bells and whistles built into the product. And then you can see over on the right, if you just want to learn DBT on your own, a developer license is free for one user, but you only get 3,000 model builds per month, or successful model builds per month. The data processing always happens in the USA. But then if you pay for it, things go up from there. So it's $100 a month per user. If you're on the team plan, you can have up to 8 people in that team, 15,000 models per month, and you get a few other features thrown in for free as well. So whenever I'm talking about DBT, I'm talking about DBT Cloud, because like Tableau Cloud, I just pay for it, log in and use it. And when there's new versions, it just, you know, I log in and just get new features, which is sometimes a little bit scary. You log in and you go, I thought that button was there and the button's moved, because yesterday the button was in this position, and overnight they've done an update and the button moved, or it changed, or it disappeared, or whatever, because that's the beauty of what they call SaaS, software as a service, where you're just paying for the vendor to keep track of all of that and upgrade things for you when they think it needs to be upgraded. So whenever I'm mentioning DBT from now on, I'm talking about cloud, but core is always the option as well. So fundamentals in DBT. There's, I think there's 3 things I've got here that we will have to talk about. The first thing is a model. Now, if you weren't using DBT and you had to be just in Snowflake building a table, there's a lot more SQL you need to learn rather than just a select. But in DBT, the fundamental thing that I'm doing all the time is I'm just writing a select statement. And we can see that I've got a model here called orders cleaned, and I've just run a select statement. We're looking at these 4 columns, we're looking at this table, and we're saying where status is not null. So my result from that would be, obviously, those 4 columns from that table, I would have a status because I'm just filtering out all the not null statuses. You could do that, and that works perfectly in DBT. What many people do in DBT is graduate to using CTE, so common table expressions, where I'm starting to, so I can say with, and I'm basically almost, it's almost like an LOD in Tableau. I'm creating this thing called completed orders, which looks like this. And then in my next step, I'm using completed orders to build this other thing using customer total. And then at the end, I'm referring to customer total. So over here, I've just got a really simple model just with a select. And over here, I've got a more complex model using CTEs to step through some processing as I go. So there's some logic embedded in the CTE here. And it's all just standard SQL. But we can see that there's a select here to generate that common table expression, CTE. And then I use it again here. And then I just refer to it at the end. And again, this is going to be a model in DBT. So I'll end up with this model called completed orders ag. And because that's available in the database, I could use that directly in Tableau if I needed to, but we're not up to that stage yet. Now, as you get more complex in DBT, you might have what they call a YAML file. So it's YAML, but the extension is always YML. And we're basically defining where the sources of our data live in our Snowflake data, again, in any database if you wanted to. So once we've got our YAML file like this, I can then write some SQL like this. Again, we're using a CTE, but I'm referring to something different now. This is not normal SQL code. And as soon as I use the double parentheses, I'm basically doing what we call a Ginger template to call in raw data orders, because over here, I've defined something as raw data, and I've defined a table as being orders. So now I'm starting to abstract where my data is actually coming from, which is a different way of saying, I don't need to hard code table names anymore. I can just say wherever orders is, and I can come back to my YAML file and change it to a different table if I wanted to, and suddenly my CTE would change. But it's doing the same thing anymore. It's doing the same thing all the time. As long as my SQL is correct, and I'm saying there's a CTE, which I'm going to call source, and then down in the next step in the CTE, I'm referring to source, but I'm now calling it cleaned, and at the end, I'm looking at cleaned. Okay, so that's a model in DBT. Notice that I have not said if it's a table or a view yet. So if you were sitting in Snowflake, you'd have to say, I want a table, and that's to store data, or I want a view, which is to calculate data. So again, it's almost like Superstore in Tableau. If I've got some Superstore data that I need, that would be a table. As Joon was saying before, the city in the Superstore has to be stored there. But the inventory calculation we were doing, that's a calculation that can be a view. Again, both of these things are database concepts that would help or hinder you in the database, depends on what choice you make. But in DBT, we don't have to choose that. We would choose that later on, but a model is just a select statement. If you can do select, you can do these models in DBT. On top of a model, we also have a test. So I can test straight away if my values are not null, or if they're unique, or if there's an accepted value list, or if there's a relationship. Or I can do some custom tests as well. Basically, I'm testing to see that my data integrity is there while DBT is running. And again, why would you do this? Because what you want to do is not let bad data get through into Tableau. So like Alex was saying with nulls and things like that, if I said you're not allowed to have nulls at all, you know, a null in a date column is really bad, or a null in a city column is really bad, I can actually put a not null constraint on that. I've got this one on order ID. So if my data is coming through and I've got order ID as a null record, DBT will actually stop processing, the test fails, and the data doesn't go down through the pipeline, so you'll never see that data in Tableau. Which means your Tableau data source won't be updated, because we're not going to update it with bad data. And then, the same as the tip before, put a modification date on your dashboard so you can see how old your data is, because maybe only today that not null constraint was violated, or the test was violated, and the new data didn't come through. And then in DBT, the concept of a DAG, which is a directed acyclic graph. I have to read that out because I never remember what a DAG is. And a DAG is basically the diagram, or how DBT remembers the order of execution of all the models. Because if I go back a step, go back a few steps, we've got all these models just floating around. Which one runs first? Which one runs second? Is there any dependencies on them at all? And if it's in a DAG, or I should say that DBT creates the DAG, and because we're using ref within our SQL, then that would be telling DBT that if model B is referring to model A, it would have to process A first before it processes B. If model D refers to A and B and C, then I need to run those three before I run D. So it actually understands all that as well, understands the dependencies. It makes your projects understandable, and you can break down the little parts into as many parts as you feel like doing. And DBT also knows when rebuilds are not necessary. So again, if I've got A, B, and C flows into D, and I've only changed D, but not A, B, and C, then it wouldn't have to run A, B, and C again. It's only going to run D, because that's the only dependency that's changed since the last time. So we might have a DAG that looks like this. I've got 3 models on my left. Again, I don't really know if they're tables or views. From a DBT point of view, that doesn't matter. But I can see from the naming convention that they're staging tables, because I just want to call all staging tables STG. But I've got organizations, I've got users, I've got user groups. They feed through into other models as they work down from left to right through the DAG, and you can see the dependencies there. This is exactly like it would look like in DBT. Again, from Tableau terms, what are you going to see? You're only going to see that last model, the dim users, after all the data's been processed, after we've transformed it in the way we want, and we end up with possibly a smaller amount of models that we actually present to Tableau. So what I'm really about, if you follow, I follow this, but I don't actually call it medallion architecture. Medallion architecture is moving things from bronze to silver to gold level. Basically, your bronze is just your raw data that's been pulled in from whatever source system we're pulling it in from. The silver level is somewhat filtered and cleaned, and your gold level is your business level. This is what Tableau is going to look at. Fundamentally, it's the only thing that Tableau looks at, because Tableau doesn't want to see all this other stuff behind the scenes. This is just working up to that main point. And our DAG would roughly sit in that medallion architecture like that. So we have the staging in our bronze, we have an intermittent table in our silver, and we have the final table in our gold. I don't think there's any questions. There's a lot of comments, but I don't see any questions in the chat, which is good. But anyway, type your questions in or type them in the Q&A if you need to. So that's Snowflake, that's Tableau, we know Tableau, Snowflake, DBT, Tableau. How does it all fit together? Again, let's go back to our modern data stack diagram. And from like every Tableau user, they don't care where the data's coming from. The middle is just a black box. No user needs to know any of this stuff. And at the end, Tableau just needs to run. Tableau's got to see all that data properly in a dashboard the way it works together. But how does it really work? So from a developer point of view, the ingestion part is pretty simple. Again, I'm only using my preferred tools. I don't care. I would like you to use Hevo and Airbyte, but again, anything to pull the data into your storage level. What works best for you? For most of my clients, Hevo and Airbyte, or a combination of the two, or only using one or whatever, is the best option to pull data from wherever we're pulling data from and go into Snowflake. If you don't like Snowflake, go and use something else as your storage layer. But fundamentally, I don't care how many source systems you've got from where, it goes into Snowflake. From Snowflake, we're going to use DBT to transform it, to put it into Tableau. But we need to look at transformation a little bit differently. So I'm going to basically pivot this around so that we're looking at it like this, because this is really what we're doing. Again, we've got our medallion architecture within Snowflake. That could be, it's pretty easy to do, different databases. I don't usually call them bronze, silver, and gold, but you sort of get the idea. In DBT, we create a model. Each of those icons down the bottom, if you like, are a model. with naming conventions if you like. Depends on what you want to do with that. I mentioned GitHub before. You need a GitHub account because GitHub does all the version control for DBT. And this is where it starts to get a bit interesting as well. DBT, as I said way back at the beginning, is more just a front end. It is for you to build your models easily and properly. It's for you to see the DAG as you're going through, but nothing gets saved in DBT. Everything gets created in DBT, saved in GitHub, and goes through and executed in Snowflake. And even to break that down a little bit further, when we're using the DBT IDE and we save something, it goes to GitHub. And when we actually want to do anything on Snowflake, so build the models or run the models or schedule it, we use the DBT engine. It's both the same thing, but here we're basically splitting it out and saying the IDE is the thing that you use on your screen, and the engine is the thing that happens in the background, especially when you're scheduling. Because like all good data pipelines, you're not going to run this manually. You're going to put it on a schedule, and that schedule could be 3 a.m. every night or every hour of the day. Maybe it's every 15 minutes of the day. How quickly and how often do you want to push your data through from bronze to silver to gold? And that's when you set up the schedule. And again, is your schedule like that? Is your schedule a monthly schedule or a manual run or whatever? The Tableau users don't care. The Tableau users see the data is actually in gold level and you can access it in Tableau. Right, so that's the analytics part at the end. Still no questions. I don't know if I'm explaining it perfectly or just no one's understanding it all, but it's okay.
It's perfect, Chris. I think it's the first time I understand everything.
Awesome, thank you.
About this topic. I just wanted to,
yep.
to be sure.
So that's all I had, and I'm running a little bit behind, but that's in closing. I would prefer you to use this software. This is my favorite sort of software. So Hevo and Airbyte. I use both of them interchangeably at the moment. Snowflake as a database. DBT, you can actually have a free forever on the developer plan, or forever until they change it. Maybe they won't. And you need a GitHub account. Even if you've never used GitHub before, you have to have a GitHub account because that's where DBT saves things to. If you want to get in contact with me, as Prasan said at the beginning, my company is Visualize Data. I'm based in Australia. That doesn't stop me in clients all around the world. So please connect on any of the socials or via the website. And I think that was it. And we can go back to everyone else and I can look at the screen properly.
Yep. Thank you so much,
and
Chris.
Happy to take questions, but I know what as well.
I can see no questions, but altogether, this whole modern data stack and how you can use them in your workflow, that was really useful for me, and I think for most of the audience, I believe here. So thank you so much for taking this topic and also sharing this knowledge with us, because most of us are kind of mostly towards asking questions to stakeholders, solving those business problems and strategy and analytics, but then this whole thing is most of the time black box, or we know like how it's moving, but to get to know about this whole modern data stack and how we can also use it and learn it, that was quite helpful. So thank you so much for that. And
Awesome.
I can see questions flowing in.
Oh, Heather was sorry. I answered Heather's question anyway. But Heather was saying that there was that I'd said that Snowflake has a Tableau public version. Maybe I don't think I did. I was more meaning that DBT has a free version. So the DBT developer account is free forever. Snowflake, when you first log on Snowflake, you get 30 days or $400 US, whichever comes first, of free, and then you have to pay for it then on. I know people that have spent or have played with their Snowflake account for 6 months. and they might spend $10 a month. I also know people who have used Snowflake outside their 30-day trial, and they can spend a few $100s in a day. Be careful what you do with Snowflake, because if you fire up a really big data warehouse or a really big virtual warehouse, or if you run it for hours, you can burn a lot of money in a day, and a lot of big companies like that. Joon was using Canva before. Canva used to spend, if I get it right, they used to spend 4,000 credits per day on their Snowflake instance. And they found a little thing in their machine learning, and they dropped that down to 800 credits per day to do almost the same thing. So 800 credits per day at $4 a credit is only, what, 3,200 US per day. And they were quite happy with that, because they've got 100 data engineers that were going crazy all day. $3,000 a day on Snowflake, not a problem at all. I can think of several of my clients, if they had a $3,000 monthly bill, they would be freaking out because it's far too much. It depends on how much you use. It depends on what you're using it for. How often are you going to take a taxi? And I'm not going to get in a taxi and drive from here to Zurich, because that's going to cost a lot of money, right? And if I take a taxi from here just 10 kilometers down the street and then get out of the taxi, and I'm only using it for this much, I'm only going to pay this much. So there's always that. Snowflake has a lot of reporting in there to show you what the costs are, but it's up to you to keep them out under control as well. It's usually pretty simple.
Question. So let's say I'm going to start learning and using DBT, and since it has a developer account, that's free. But however, as you mentioned, it's not something that stores and gives you the output, but I have to commit it to GitHub, and then it's writes back to a database. So at least I need to have a database or a warehouse as well if I want to execute this pipeline. DBT itself won't be able to help me with the transformation and get me the output.
No. DBT is just a tool that works on top of a database. You have to have a database somewhere. I would still recommend that if you're thinking of learning DBT in Snowflake, set up your own Snowflake account, put your own credit card against it, right? And the same thing is you can set up Snowflake to say, warn me if I'm spending more than $10 a month. Warn me if I'm spending, what is your personal budget? But again, make sure you're using Snowflake properly and have things auto-suspending, because I have seen one Tableau user burn through $400 US in one day just using Tableau against Snowflake, because they set it up the wrong way, and suddenly the cost goes through the roof. I should put a guide on my blog about how to do that, but yes, I might do that as well.
That will be really helpful for all of us going to adopt this.
But it doesn't cost much to learn that sort of stack, and there's probably, off the top of my head, I'm sort of thinking of some 100% free options, but I'll research that before I promise that it's 100% free.
Sure, thank you so much. Okay, so I think we are done for the day. So thank you so much, everyone. Thank you, Joon. Thank you, Chris, for the session. And thank you, everyone, for being here, also keeping the chat busy. I think we should have some award for whosoever brings in more wildness to the chat, right, Annabelle?
Thank you very much, everyone. And you can already register for our next month. It's page is already up, not complete, but up. So, and you see, Chris, 2 people agree with me that we should have a data engineering TUG.
Or if you want to run another TUG, then go for it.
I don't have the knowledge to run that.
It's sort of, in a way, I think it's cheating sometimes, because the data ingestion side is just so easy to set up and so easy to run. So again, I'm doing a few little projects in the background that I'm sort of looking at that sort of stuff. But yeah, it's pretty easy to get set up and going with this.
Yeah, but
because
when
of
we
time.
have someone explain it to us
Yeah.
so well than you.
So at the conference, I heard from Rika.
Yeah.
She has started a new tug that is on data stack or modern data stack,
Oh, yeah?
Okay.
as I remember. Yes. Because I was having conversation with her and she told me about like with all the different data stack that can be used with Tableau, she has already started a tug. I haven't checked it out,
Wow.
but
I
I
haven't.
think
Yeah, I haven't seen that at all. I'll have to ping her and find out about it.
yeah.
Anyway, thank you very much,
Good.
guys.
Okay. Thank you.
See you
All
soon.
right.
Thank you, everyone.
Bye-bye.
Okay.
Good
See
to
ya.
see you.
Bye.
Bye.